Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at position vectors. We are going to look at positioning vectors in the Cartesian plane. Now, in a previous video, I told you that when it comes to vectors, all we care about is their magnitude and direction. We don't care about their starting point. So we can start the vectors from anywhere. So in the Cartesian plane, it's just easier if we start them from the origin. So u here is the vector that goes from the origin to the point 8, -6. We write u in this form. X coordinate or x component goes before I, y coordinate or y component goes before j. So we're going to calculate this, which means the magnitude of u. And we can do that easily using Pythagoras. We just draw a right-angled triangle here. This distance is 8. This distance is 6. So the magnitude of u is simply the square root of shorter side squared plus shorter side squared, and that gives us 10. So more generally, if you have a vector ai plus bj, its magnitude is just the square root of a squared plus b squared. So now we're going to look at finding the direction of a vector. Now, another way that you can represent a vector rather than in this form using Cartesian coordinates is to use polar coordinates. So they also use two numbers. R is the radius, it's just the magnitude of the vector, and theta is a measure of its direction. Now we call R the radius because see how this vector had magnitude 10? All vectors of magnitude 10 would lie on a circle, and this is kind of like the radius of the circle. So we're going to look at writing u in polar coordinates. So we know that R is just going to be the magnitude, which is 10, and we're going to find the angle theta by using tan inverse of b over a. Tan inverse of y coordinate over x coordinate. That's just using simple trigonometry. See, when we're talking about the direction of a vector, we want this angle here. We always want the angle made with the positive x-axis going in an anti-clockwise direction. So if I put in my calculator theta equals tan inverse, now b, the y coordinate always goes on top, 6 over 8. Make sure you include the negatives if they're there. And that makes sense because it's just opposite over adjacent. So if I put this in my calculator, I get minus or about minus 37 degrees. Now, when we're representing the direction of a vector here, we want to use an angle between 0 and 360. So these numbers 0, 91, 82, 70, 360 are the same numbers you'd be used to from the unit circle. This angle here is 37 degrees. That's the magnitude of the angle. But we want to avoid ambiguity because if I just represented this as 37 degrees, there's another vector here with magnitude 10. That's 37 degrees from the positive x-axis. So instead of using this angle here, we're always going to use the angle made with the positive x-axis in an anti-clockwise direction. That angle there is going to be 360 minus 37. It's going to be about 323 degrees. So the way I represent u in polar coordinates, first number is its magnitude, and the second number is the angle made with the positive x-axis going in an anti-clockwise direction. Now, if you start with polar coordinates and you want to go to Cartesian coordinates, that's really easy. In Cartesian coordinates, it's just r cos theta, the x value, and then the y value is r sine theta. So if you put 10 cos 323, you should get 8, and then 10 sine 323 gives you -6, and we're back into Cartesian coordinates. All right, let's now look at adding and subtracting vectors. So if we want to add and subtract vectors, we don't always want to draw a picture or draw up a Cartesian plane like we were doing in a previous lesson. If you want to add or subtract vectors, you simply add their x and y components separately. So if u is this vector and v is this vector, and I want to find u plus v, all I do is add together the two x components. 5 plus 3 is 8. So we always put an I after the x coordinates, and then we add the y components. -2 plus this will be 1. J is the same as 1j. So -12 plus 1 gives you -11. This will be 8i minus 11j. Note that addition with vectors is commutative just as it is for numbers. So v plus u would have given us the same answer. On the other hand, u minus v, this vector subtract this vector, we just go x component minus x component. So 5 minus 3 is 2. We put an I after the x component, and then minus 12 subtract 1 is -13. We always put a j after the y components. Now, if you want to find the distance between two vectors, you just subtract them like we did here, and we calculate their magnitude. So the distance between this vector and this vector, this is basically the distance between their heads, between their endpoints. We just take the magnitude of this vector here. It will just be the square root of x component squared plus y component squared. It will be exactly the square root of 173, probably about 13.1 or something. So now we're going to look at unit vectors. So unit vectors have the same direction, but their magnitude is always equal to 1. You calculate them by dividing each component by the original magnitude. What does that mean here? Well, this means the unit vector going in the same direction as you. We want a vector that goes in the same direction as this. It goes toward the point 5, -12 from the origin, but we want its magnitude to only be 1. So the magnitude of u is just the square root of 5 squared plus 12 squared. The magnitude of u is equal to 13. You can just use your calculator for that. So if I want to find a unit vector that goes in the same direction as u, all I need to do is divide by this magnitude. So what I can do equivalently is times 1 over the magnitude by u. So 1 over 13 times u. I am just using scalar multiplication here. I go 1 over 13 times the x component, so that'll give me 5 on 13i, and then 1 on 13 times the y component. So you can easily check here that this vector has magnitude 1. It will have the same direction, same angle as the original vector u. It's just like a smaller version of u. One other thing we need to be able to calculate is the unit position vector locating u from v. So this is if you start at v and you draw a vector towards u, but because it's a unit vector, its magnitude is only 1. So all we do is find the unit vector of u minus v. So u minus v, we figured out before, was 2i minus 13j, and it had a magnitude of root 173. So all we're going to do here is multiply 1 over the magnitude by the vector that we found that was u minus v. So this is just scalar multiplication. It'll just be 2 over root 173i minus 13 over root 173j. Once again, this vector is going in the direction of u from v. Starting here, moving towards this vector, but it has magnitude of 1 because it is a unit vector. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.